Hey friends, welcome back to Civil Engineering Mastery. In this video, let's discuss about column pedestal. As we all know that we provide column footing. So along with that column footing, we provide pedestal. So let's discuss what is pedestal and why do we need to provide pedestal, what are all the functions of pedestal and what are all the advantages of pedestal in column footing. So let's begin now. First, let's start with what is pedestal. Here look into this image. This is footing and this is pedestal and this one is column. We know what is footing and what is column. Now what is pedestal? Pedestal is also a vertical compression member which is provided in various locations of building as per its purpose. So according to the purpose, it is provided in the various locations. For example, here in concrete footing, we provide the pedestal like this, and when we construct a steel column or steel structure, below that also we provide this kind of concrete pedestal. And in some places, pedestal is provided for aesthetic purpose as well. So pedestal is the vertical compression member which is having the length to least lateral dimension ratio less than 3. So this is very important. Its length to least lateral dimension less than 3. Pedestals are provided to carry the load from the supported elements like column, and it transfers the load to the footing below. Generally, pedestal width is greater than its height. Sometimes pedestal is provided for the architectural purpose. In this condition, pedestal is not designed as a vertical compression member. It is just provided for the aesthetic point of view. As I told you before, in some cases for the architectural purpose or aesthetic purpose, we do provide pedestals. So in that case, pedestal is not designed as a vertical compression member. It is just provided for aesthetic purpose only. Pedestal may be square, rectangular or circular in shape. Next, let's look into the functions of pedestal. These pedestals are provided to spread the load over large area. You look into this picture, when the column load is transferred to the pedestal, this pedestal transfer the load to the wider area of footing. That footing in turns transfer the load to even wider area of soil. So from this we get the uniform soil distribution. In the absence of pedestal, as you can see here, the concentration of load at the center of footing will be more. So this reduces the load bearing capacity of the soil. If we provide pedestal, that increases the load bearing capacity of the soil. And with pedestal we get uniform load distribution, and without pedestal we get non-uniform load distribution. Next one is to avoid contact between metal or wooden elements. These metal or wooden elements or steel plate, steel columns like this will be easily affected by the moisture conditions of the soil. So the corrosion or weathering may occur. So in order to avoid that, we need to provide this pedestal just above the footing on which these metal or wooden elements are resting just above the ground surface. So these pedestals are provided to avoid the corrosion or weathering action of steel or wooden elements. And if we provide pedestal, that increases the durability of the column. Next one is to avoid punching shear failure. As we all know that what is punching shear failure. It is also called as two-way shear failure in footings. So if the loads coming on the column is more, we need to increase the depth of the footing in order to avoid the punching shear failure. Punching shear failure will occur at the distance of d by 2 from the face of the column. So if we provide pedestal, we can reduce the depth of the footing, and only in this area we need to provide more depth, and we can provide the thinner footing. This pedestal helps to avoid the punching shear failure. Next one is to provide support for elements at some elevations. As we have discussed before, pedestals are provided for architectural or aesthetic purpose as well. In that case, we don't need to design the pedestal as a vertical compression member. It is only provided for the aesthetic purpose. So in some elevation, we can also provide pedestal like this. So this is not a load carrying element now. It is only provided for the aesthetic purpose. Now let's look into the pedestal detail. Here we have the plan of the footing. So this is the footing area, size of the footing, and then here we have the column. In the middle we have the column, and this is the pedestal. If you look into this section, you will come to know. See here, this is the footing, thinner footing, and this is the pedestal, and this is the column. So here pedestal is designed as a plain cement concrete pedestal. It is not a reinforced pedestal. If the load is coming on the column is less, then we can design the pedestal as a plain cement concrete pedestal. If the load is more, then we need to provide the reinforcement for this pedestal as well. Let's look into the IS code recommendation for this pedestal. In IS 456-2000 class number 34.1.3, in case of plain concrete pedestal, the angle between the plane passing through the bottom edge of the pedestal and the corresponding junction of the column with pedestal and the horizontal plane shall be governed by the expression. If you check in this figure 20, see this is the pedestal, plain concrete pedestal, and this is the column. Tan alpha shall not be less than 0.9 times root 100 Q naught upon FCK plus 1. This is the formula which is given in IS 456-2000 for pedestal. Next, let's look into the pedestal with reinforcement detail. So how we need to provide the pedestal reinforcement. So this is the reinforcement arrangement, like how we provide the bars for column. Similar way we need to provide the bars for pedestal as well, but the height of the pedestal will be less when compared to column. And this is the ties. If you look into this section, it is clear. This is the reinforcement, pedestal reinforcement, and this is the column bar. So in this way, you have to provide the pedestal reinforcement arrangement. This DP is depth of pedestal, and here it is column reinforcement and column ties are provided. Let's look into the pedestal details, how the pedestal reinforcement details we need to provide. Here, this is the column size 230 by 750 column size, and this is the outer dimension, that is pedestal size 530 by 1050, and pedestal reinforcement, if you check, it is 12 numbers of 12 mm dia bar. See, this is 12 numbers 1 2 3 4 5 6 7 8 9 10 11 12 numbers of 12 mm dia bar, and the tie reinforcement is T8 at 250 mm center to center. Similarly, next column size is 300 by 600 and pedestal size is 600 by 900, and here also it is 12 numbers of 12 mm dia bar, and ties reinforcement is T8 at 250 mm center to center. This column is also similar to this one only, but only the size is different. And here let's look into this column. Column size is 600 by 600 and pedestal size is 900 by 900. If you look into the reinforcement, it is 20 number of 12 mm dia bar, and the ties is T8 at 250 mm center to center. Similarly, for this column, 600 by 900 is the column size, 900 by 1200 is the pedestal size, and the reinforcement is 24 numbers of 12 mm dia bar. Ties reinforcement is T8 at 250 mm center to center. So this is how we need to provide the pedestal reinforcement. So friends, I hope you all like this video. Please do comment in the comment box. Your comments are always welcome. Also share it with your friends if you like this video. Don't forget to subscribe the channel for more videos. Thank you for watching.